Oh man, this is sick. I mean, it's going to be awesome here. It's going to be quick too. We're going to go over the derivative of e to the x. And it's actually so simple. So what I'm going to do in this video is I'm going to start out just first by teaching you the process. Then I'm going to show you why it makes sense that the process works. All right, so the process is super simple. Y equals e to the x. If that's the function, the derivative, are you ready for it? It's itself. It's actually e to the x. It's such a fast function that its derivative loses no power at all. It's e to the x. So then what happens if you have e to the u? Well, the chain rules involved there, that would be e to the u times du dx, or times u prime. Or e to the stuff d stuff. And that's going to sound familiar. So e to the stuff d stuff. That's it. It's itself times the derivative of the stuff, the chain rule. That's all. What? I know, right? You're probably like, let's keep going. So let's actually practice it now. It's not so bad. The derivative, y prime, of e to the x squared. We're going to differentiate each function. So that'd be e to the stuff. Keep it exactly as it is. E to the stuff, d stuff. The derivative of x squared, 2x. And that we can rewrite as 2x times e to the x squared. That's all. That's not bad. All right, this one right here. Keep the 3 just chilling. It's a coefficient. Then we've got e to the stuff, d stuff. E to all of that junk times the derivative of minus x over 5. Well, that's like minus 1/5 x. The derivative of that is minus 1/5. We'll combine everything together. 3 times negative 1/5 is negative 3/5. E to the minus x over 5. Oh, man, that's nice. And then last but certainly not least, dy dx. The 5, oh, wait a second. We've got a product rule, but the 5's going to chill out. All right, let's just leave the 5 to the outside. Notice you got a product. That's cool. We got this. First, d second. First. Now we get to the d second. Now we just hyper-focus on the e to the x rules. D second is e to the stuff. D that stuff is cosine x. Plus second, d first. Now remember, I factored out the 5, so d first is just the derivative of x squared. So that's times 2x. Let's fit that in there. And now all we're going to do is just multiply through. And we've got that down here. So we're going to multiply through by the 5. Make sure we do that right. I did that wrong and had to edit this video a little bit. How about that? So 5x squared e to the sine x. We'll just keep the cosine x underfoot right there. 5 times all of this is going to be plus 10x e to the sine x. That's the error that I made. Exercises. That's all. That's all there is to the derivative. So why is the derivative of e to the x itself? So let me go over that now. As always, the derivative is the slope, right, generator, right? It's the function that gives you the slopes of the original function. So y prime is the same exact function. Why is that? Well, if you look at this, the tangent line anywhere is really steep. And so the rate at which the tangent lines are growing is really steep too. So that exponential function makes it so that you actually don't lose any slope. Whereas like with x squared, it becomes 2x. It goes down a power. Exponential so fast, you don't lose any power. That's one way of thinking of it, but I'm going to prove it to you. So if y equals e to the x, and then we're given that, we're like, well, how do I find the derivative of that? I could always take the ln of both sides. So ln of y, we'll use logarithmic differentiation here, equals ln of e to the x. Well, ln of y stays. We haven't taken a derivative yet. And ln of e to the x is x. ln and e undo each other. They're inverses. So now we're ready to take a derivative. We want to solve for y prime. So the derivative is 1 over stuff d stuff. Isn't that cool how we're using ln in all this? I think it is cool. And that's equal to the derivative of x, which is 1. We'll multiply both sides by y. You get y prime equals y. But y was e to the x. A neat little proof. Oh, it's beautiful. So that's it. That's why the derivative of e to the x is e to the x. In the next video, I'm just going to go over some old school concepts with this new school derivative of e to the x. It's pretty sweet. I'll see you there. Peace.